sorry, I was just looking at something else. What did you say?
I will leave and join.
Oh, okay.
Yes.
All right. Hello, Martin. Dietra will be right back. We'll be getting started shortly. Let's see who I'm expecting that I don't see yet. Well, Doug is supposed to be here. I don't see him. This is one of those days where everything seems to be going wrong. Okay, let's see, where is Dieter back? Oh, Martin's in the queue. Martin, did you intend to? Oh, can you test your screen? Oh, yes, absolutely. Sorry, I wasn't looking at the chat. Hello, Marco. So Martin, you should be able to share. There you go. Excellent. So Tal, either we can share your slides or you can share them. Do you have a preference?
Go ahead and share them.
Okay. And I don't see Doug online yet. Tiny bit worried about Doug being able to use Meet Echo successfully. There you go, Dieter. All right. Do you want to get the chair slides up? And let's see how we're doing on folks. See, we're beginning to get critical mass. There's one or two more I'm looking for. But I think, let me send one quick text message. It's a reminder. All right, let's go ahead and get started. Welcome to the NTP working group. A couple quick things before we get started. For those of you who are new to the tool, I know that a number of you are one-day pass participants, and so you have not had 4 days to get used to our online tool for this meeting. If you wish to send audio, so that at the top you see you have your name, and then below that there's a white bar, and there you'll see, going left to right, you'll see a screen request, a camera request, an audio request, and then the fourth one on the far right is audio on all the time. So generally speaking, you won't be doing that. So we'll manage the queue just like we have in other meetings where we've had, if you remember the other queue mechanism that we had. You will need to request to send video and audio separately. They are two separate streams, and they're independent. So when you get in the queue, you can request audio only or audio and video. And then if you happen to be sharing slides, obviously you can request your screen access as well. The second button over, you can see under the oh yeah, and I've also been reminded that there are tooltips, but they're over to the right, so sometimes you don't see them. And you can see under the participant, you can see who the participants are and who's in the queue, or you can see the Jabber chat room. And if you are monitoring, it's the same Jabber, it's NTP, the NTP room at jabber.ietf.org. So hopefully that's enough of a quick check. So with that, next slide, Dieter. So this is the IETF Notewell. By participating in this meeting, by signing up to attend, you have agreed to abide by all of the policies that are articulated here. If you have any questions, feel free to reach out to Dieter or myself, or to Eric Klein, our AD. Next slide. This is our agenda for today. We have welcome and note well administrivia section, NTP document status, the Yang data model for NTP, which is going to be very short, port randomization for in NTP, which could also be very short, the alternative NTP port, the Chronos work, rough time, and these are all existing working group documents. And then we have working group documents without updates. And then I didn't get a chance to double check this at the last minute because I lost power. And so I am crashing at a friend's house for the moment so that I can actually do the meeting. So I lost about 12 hours of my prep time. So I don't remember. I'll be checking on that as we go. Martin's going to tell us a little bit about the hackathon last week for NTS, and then we're going to talk NTP v5 development. Is there any agenda bashing? All right, so hearing no agenda bashing, the other thing is we aren't going to get a Jabber scribe. If you don't want to speak at the mic, just put mic in front of your word in front of your words in the Jabber room, in the chat room, and we will catch it. I'll be monitoring the chat as the meeting goes, and Dieter will be managing the slides. So with that, Oh, and Tal Misrahi has very generously agreed to take notes. We definitely appreciate that. So if there is, I don't believe there's any other questions. I'm still, okay, Doug can't get in. So this would be why. Hold on one second while I see if, I just want to send Doug a quick note to. Okay, so NTP document status. We have two documents in the RFC editor queue, the NTP packet timestamps and the NTS document. For those of you who attended the plenary, you understand that there is a bit of a delay in the RFC editor queue right now because they got a huge dump of the cluster 238 documents all at the same time. So that is fine. The next document is the control, the command mode 6 messages. And Eric, this is something I should have checked with you before the meeting, so I'll go ahead and do it now. Are you waiting for me to update the Shepherd, or am I waiting for you on something? This is kind of an embarrassing question at this hour, but.
No, I'm embarrassed that I don't know, actually. I was just looking at that actually in AD follow-up, and it says that there's like, you know, like as if it were a standards action or a BGP thing, but it's state changed informational. So I will figure out what's going on and what I should do, and I'll follow up with you guys.
Okay, thank you. I thought there was also something I was supposed to do, but I'm not. I think I'm supposed to update the rate up, but anyway. So we'll take that offline. So those are the three documents that are in process. So the next item in the agenda is the Yang data model for NTP. I know Dieter was working on the Shepherd write-up. I don't know. I actually don't know. Dieter, did you get that submitted?
The Shepherd write-up is nearly finished.
Okay.
There are two questions which are still open, and I will send questions to the author frequently.
Okay, excellent. So that document is in flight. The port randomization document has been updated since the last meeting, and all the issues on the mailing list were addressed. I don't see Fernando here, but I believe that we're ready to go forward with the working group last call on this. There was no further discussion on that document? Okay, so excuse me, Dieter and I will get a working group last call for that one out. I believe the discussion at the virtual interim was that we would, when the document had been updated, we would proceed with the working group last call. Next on the agenda is the alternative port for NTP port. I don't believe there's been any updates since our virtual interim. And it is still a individual submission. So Miroslav, did you want to say anything about that, or are we just at the stage where we need to do a call for adoption? And there you go, Miroslav.
Hi. I think we talked about this on the last meeting, that there will be a call for adoption.
Okay.
And there were no changes in the document since then.
Okay. Okay. Excellent. I was pretty sure that was the thing with that. So those were the three documents that are those three documents. So the next one is the Chronos document. This is an experimental RFC on a mechanism for NTP. Tal, I believe you're going to present the updated draft. Do you want to request audio as well? There you go.
Okay, excellent. Okay, so can I go ahead and start?
Yes.
Okay, so this draft is a joint work with Neta, Dani, and Michael, who are from the Hebrew University. And this draft has been around for a while, but in the current version of the draft, there was a significant change that we want to present today, and we want to hear some feedback about that. Next slide, please. Okay, so just a short reminder about the threat model we were talking about. We're talking about situation where we have an attacker or a few attackers which gain access to some of the servers in the NTP pool. So for example, it can be a very large number of servers, or it can be a small number of servers. So let's just take an example. Let's say that the client has access to a few hundreds of servers and chooses, say, 4 of those servers. So if it happens that 2 of these 4 servers have been compromised by an attacker, that's already a problem in NTP today. But Chronos can handle that. Okay, so that's the threat that we're talking about generally. And we're assuming that attackers either have access to an NTP server, or they have access to the path between the client and the server. Okay, man-in-the-middle attacker. So each of these cases is a bit different, but the outcome can be the same, either by manipulating the NTP messages or by delaying them. The attacker can basically compromise the client's synchronization. Next slide, please. Okay, so a general reminder of what Chronos does. So first of all, the basic thing is that Chronos connects to a very large number of servers. Just when I say connects, just a calibration process where it gains access to a large set of servers, let's say 100 or a few hundreds of servers. But in each poll interval, only a small subset of these servers are chosen and polled. And this small subset can be, for example, 4 servers or 10 servers, a small number of servers, because we don't want to overload the NTP servers. But the main concept, which is important here, is that in each poll interval, a different subset of these NTP servers is chosen. So from these hundreds of servers, in each poll interval, we choose, let's say, 4 different servers. And then in each poll interval, based on these few servers that were accessed, the client performs a filtering algorithm, which gets rid of false stickers and also does kind of an average in order to improve the precision. Next slide, please. Okay, so there's a typo here in the title. It should be Chronos and NTPv4. So basically, if we compare Chronos and NTPv4, there are a few differences, but there are 2 main differences. So in Chronos, we have a larger set of servers that are accessed, so that in each interval, we choose a different subset of servers. So obviously that gives us more variety, and that reduces the security risks when we have a set of servers that are compromised. So that's the advantage. But the disadvantage that was discussed in previous IETF meetings is that when you choose a different subset of servers each time, obviously that affects the precision. So the precision may be compromised if we take that approach. So in the current draft, what we tried to do is think of Chronos as a watchdog, kind of a watchdog process that in each poll interval, it takes this different subset of servers and computes a virtual clock based on these different servers. And then we compare the outcome of the Chronos algorithm to the conventional NTP-v4 algorithm. So most of the time we use the NTP-v4 algorithm, which has the same characteristics that we're familiar with. It's the same stability, the same precision, and so on. But then Chronos is used as a watchdog for detecting security attacks. Next slide, please. Okay, so the idea is that both of them run in parallel, and in each poll interval, we compare the result of the clock value of NTP-v4 to the clock value of the Chronos watchdog. And if the difference between these two clocks exceeds a certain threshold, let's say a few tens of milliseconds, we're assuming we're under attack. And since if we are assuming we're under attack, in that case, we start using the Chronos algorithm rather than using the NTP-v4 algorithm. So most of the time, if we're not under attack, if everything works reasonably well, we'll be using the conventional NTP-v4 algorithm. But in these situations where some of the servers are compromised, we're going to use the Chronos algorithm. So basically, this approach kind of allows us to enjoy the best of both worlds, to have the same precision that we're familiar with, but in cases of security attacks, to enjoy the benefits of Chronos. Next slide, please. So what are the next steps? First of all, working on implementing Chronos as a watchdog. And if people are interested to implement it, Chronos, will be happy to hear about that, and we'll be happy to work with people who are interested in that. We're also continuing to evaluate the performance of Chronos as a watchdog. And we're looking for feedback, especially about the current version of the draft and about this approach of using Chronos as a watchdog. So any feedback right now or on the mailing list would be welcome.
All right. Is there any questions or comments? So when you say you're working on implementing Chronos as a watchdog, is that the university that's doing that implementation?
Right. Yeah. When I say we, I actually mean Neta and the team the team that she's working with in the Hebrew University. And we've also been talking to people from the working group, but basically, I think that the current work that we know is in some kind of progress is Neta's team who are working on it.
Okay.
I have a question. The smart filter mechanisms you are using in Chronos, are they the same as in NTP?
It's not the same, but it's based on the same concepts. The concept of using agreement algorithms have been well established for 30 or 40 years, and the idea is that you basically you take the top third and the bottom third and you ignore them. You only take the middle third of the samples, and then you do some kind of either an average or a median from these samples. So the concept is not identical to NTP, but it's pretty similar.
Okay, thanks.
Go ahead, Netta.
Do you hear me?
Yes.
I wanted to add this to the discussion you had with Tal regarding the implementation that we started to implement in the university, and we will be very happy if someone from the group can work with us on implement it in order to have much a whole implementation that we can someday use as a part of the NTP v4 or maybe v5 as a watchdog. So we are welcome. You're very welcome to join us and work with us on the Chronos implementation.
Okay, thank you. Are there any other questions on this? Okay, just looking at the, so part of the reason why this was on the agenda this time was we haven't discussed it recently. I will note that the draft has been up since March, and at the time at which we discussed it as a working group document, there was consensus to adopt it, but now we need folks to provide comments. So it would be really helpful if people would review. Tal, if maybe you or Netta could send a reminder to the mailing list along with a pointer to the document and ask for comments, and also any feedback on folks that might be interested in implementing it. Okay.
Sure, yes, yeah.
I also know that we had discussed it both as an experimental draft and as an informational draft. I know that it's currently informational, and depending on feedback on implementations, we might want to think about what's the right status. So that's something, if you all could be thinking about, that would be helpful. Anything else? Okay. So
Thank
with
you.
that, you're welcome. So the next item on the agenda is rough time. Now, we did discuss rough time at the virtual interim that we had, and there has not been an update since then. Are any of the rough time authors here, and do they want to comment on the status of updates to that document? I don't actually see them. Okay, I don't see anybody from that group. Actually, as it turns out, we're covering all the working group documents without updates, so I think we're good there. Next up on the agenda is the NTS Hackathon and any further NTS development or deployment updates. Martin?
Martin, do you want to share your screen?
So, can you hear me?
Yeah, I think Martin was going to share his screen.
Okay, then I will.
Okay, so there you go, Martin.
So, okay.
There you go.
Is everything
Works.
fine? Can you hear me?
Yes, I can.
I hope so. Okay.
Did we lose Martin? Or did I get lost? I don't think we have your audio. Okay, you got it. You should have audio and screen. I show both of those transmitting. You might have, there is a little circular thing in the bottom that reconnects your audio that sometimes helps. Okay, let's do this again. I see you requesting to share your screen, but I don't see you requesting audio. Okay, there we go. I've granted you audio permission. Go ahead. Right, Martin, I don't know if you can hear me, but as Meet Echo has pointed out, are you transmitting anything? Can you see the little bars? Yeah, you were. He was there right at the beginning. Okay. Some of the other working groups had this music queued up for hums. We need that music right now. Okay, I've granted you audio. I've granted you screen permissions. So you're getting ready to share your screen. Are you speaking? I hear noise. We even tested this in advance. All right, Martin. Maybe you should do just audio. Okay, you don't see the waveform, then you're not transforming and you're not transmitting anything locally. So do you have something muted somewhere? Okay. You can't hear me either. Okay. So while you're doing that, Doug, do you want to, let's see, do we want to switch and do Doug next?
Yep.
All right, Doug, do you want to, so
I think I will share the screen. I will share the.
you're going to share the slides and just let Doug talk to them?
Yep.
Okay, so Doug, are you ready to try the audio cue? Okay, let me see. Doug Arnold. All right, I granted you the audio cue. Can you speak, Doug?
Can you hear me?
We can, yes.
Oh, okay, good. Okay, so this is a proposal. At this point, it's just a conceptual description on NTP-V5 modular architecture. It's a little bit expanded from a previous version that I posted on the email reflector. So the idea is to divide NTP-V5 into two major subsystems, which I'm calling the timing engine and the protocol engine. And the whole point is to allow NTP to be kind of set up for specialized applications that might need either the timing engine or the protocol engine to act a little differently than it does for the general purpose IT case. So examples of different timing engines is one would be that's very precise, maybe for financial networks, and one that's just for general IT setting, log file, timestamp, timing, and this sort of thing, security ticket timeout. And examples for protocol engineers, maybe there'd be a version with security and without security. Okay, next slide. So this is kind of a functional block diagram view. This is not the latest. No, yeah, it is. Sorry. This is it. Okay, so this is for the client. The idea is you see the timing engine and the protocol engine. They both interact with a management interface, and they have an interface to each other. The protocol engine pulls time to populate timestamp fields in packets and sends them out. Timing engine gets the timing data from received packets and use that to create clock corrections. And here there's two possibilities. It could be software timestamps from an operating system clock that's steered, or it could be, if it's a hardware timestamping situation where you have a counter on a PHY that you can steer, then that would be also another possibility for the clock that's being steered. Okay, next slide, please. So for the server version, we add also an external timing reference. This might be a GPS receiver, for example, and it's going to bring time in. And now the timing engine actually has to get time from the clock so it can compare it to its reference and steer that way. And that's the major difference between this one and the client version. And note also, depending on the implementation, the management interface might have its own network stack on a separate card or something. It just depends on the implementation. That's not important. Okay, next slide, please. Okay, so a couple of notes on the local clock. It can be an OS system clock and can be a steerable counter. If it's a kind of not a general purpose hardware, but some kind of specialized thing, then it might have a custom hardware clock, for example, implemented as an FPGA or something like that. Timing engine, as I said before, clients don't need to read the local clock. That was a question that came up when I put this on the email reflector. They don't actually need to read it. They get that timing information passed to them from the protocol engine. But for the server it does, so we can steer to the reference. Okay, next slide, please. Okay, the protocol engine. This is what it does. it interfaces with the network stack, builds the packets for transmission, fetches the timestamps, and when packets are received, it parses them and pulls out all the fields, puts them into some kind of data record. If there's security, that's part of the protocol, so that's executed, key management and the whole bit. In my proposal, the protocol engine decides exactly when to send packets based on some kind of average packet interval, packet rate that's determined by the timing engine. So the timing engine might say, I want you to send packets to this server, once per second or once per minute or whatever it is, and then, but the protocol engine, picks the exact moment when, okay, it's been long enough, I'm sending one, and that can be based on randomized time or just a constant interval, however the standard ends up defining that, or if there's options. And then it passes the received information of what just happened.
It looks like Dieter got dropped. Oh, he's coming back.
It's coming back. Okay. It passes the receiving information, all the timestamps and the important timing metadata to the timing engine, which includes things. And I'll go through that. I have another slide on that. So let's move on to the next one, please. Okay, timing engine. Okay, based on a suggestion I got on the email reflector, the timing engine should select the servers to receive from, and then as I look into what all the timing engine does, it makes total sense because the timing engine is analyzing how good the data is from different servers, and so. For example, false ticker identification. So the timing engine needs to be able to say, remove that server from the list or add another one. And it does any kind of glitch detection, any kind of lucky packet pre-filtering or something, and then it steers the clock so it's got a PLL and talks to whatever driver is needed to talk to steer the clock, or in the case of software, OS system calls. And and generates any kind of statistics or performance metrics of how the timing is working if it's a client, I guess if it's a server, it generates information about its reference and how well it's tracking the reference. Okay, next slide, please. Okay, so this is kind of a look at the interface between the two. From the timing engine, we get a list of target server IP addresses and the desired average packet time interval for each server. From the protocol engine, if one of those servers isn't responding, then it reports that back. And since that has to happen, since the timing engine is one that's selecting them from some list, it needs to know which ones are unavailable. And then every time a packet's received, there's a data record, which has all the timestamps, information about the server. If it's a, this is from the client view. Things about leap second, what's the status of the server, security on off. So this is sort of the client view. Actually, I need to generate one of these slides for the server view as well, what it looks like, because then that information on the timing, all this information on stratum and leap second, that goes the other way from the timing engine to the protocol engine. Next slide, please. Okay, so that's as far as I got on this so far. Obviously, it's very preliminary. We're just starting to think about this. I'm happy. First of all, I want to thank Ulrich and Hal Murray for, they had lots of good questions and suggestions. They helped make this a little better, but I don't blame them for the things that are still need work. That's my fault. I would like to draft an architecture document along these lines, and I'm looking if anyone wants to help work on that. Please let me know. That's my email address. And that's all I got today, unless there are questions.
Go ahead, Miroslav.
So is the plan to have one document that covers even the protocol? It seems to me this is about a design of a server and client that would be recommended, right? So it wouldn't be required. Like anyone would be free to implement it slightly differently, but the protocol needs to be specified strictly. So is that supposed to be separate or everything in one document?
I think it would be easier to have, if there's going to be more than one version, it might be easier to have separate documents, as you suggested. I think having a protocol document that says this is the structure of the packet and the general ideas about the sequence, and there would be an architecture document that would sort of explain the concept and define in more detail than I've shown today this interface between the two. And then another document that would be the timing engine description. And I think out that
I think from a this is just an opinion perspective. It's not from the perspective of the chair, but we don't. Your original question, Miroslav, was, is that the plan? And I think the point right now is we're really in a discussion mode and we don't have a solid plan. I believe we originally envisioned something like a protocol document and an algorithms document where the protocol itself would be standards track and the algorithms might be informational. But again, we don't have working group consensus. We haven't actually done an update to the charter to even cover the work yet. So this is really these are preliminary discussions. So I would appreciate thoughts on what the plan should be to help us formulate them.
Yeah, Karen, I wanted to point out one thing. What's driving all this? Why am I proposing this? What I've seen is that people are already doing this with NTP-v4, non-standard. It's not described anywhere in the IETF, but there are these sort of proprietary versions of NTP for niche applications, and the one that comes to mind is financial IT. And these people say, "Oh no, we're doing NTP," and I'm like, "Well, you have your message rates and your clock control filters and algorithms are different than what's described in the IETF. So you're kind of doing a non-standard NTP, but they're so since the people are already doing this, it's in live networks in the field. It seems like there really is a need.
Right. Well, I think we've been discussing for a little while now that there is a need to have some sort of an NTP-v5 effort, and what that actually looks like is what we're in the preliminary stages of discussing. So I do think some some individual drafts along this line would be very helpful as well. Any other questions?
I have at least two questions. Okay, thanks for the design very much. I have a question regarding the timing engine. Does it, or I thought it might make sense to separate the clock control from the timing engine. Is that that's a question to you. Would this make sense?
To separate the clock control from what? I missed that.
From the timing engine.
So you have clock control is kind of a separate entity, and the timing engine just does the analysis and runs the algorithm. Would the clock control include a PLL filter at all, or would it just be sort of like a block that communicates with whatever clock there is, that so that you could have different kinds of clocks?
Requirements regarding how fast the clock has to be adjusted. I know at least of one requirements where people would not accept a long adjustment period, but rather would like to have a clock hardly set, even if time is set backwards.
Yeah, I mean that it's possible. There certainly are different kinds of clocks that you have to talk to. They have different requirements. My one concern is I don't want to have too many subsystems that are separate, because then I think it can get very complicated with many combinations. But that's debatable.
Okay. Another question I have is on the protocol engine, the packet structure. As far as I understood it, still contains the timestamp T1. Is that good?
Yes, it contains the timestamps, and those are put in by the protocol engine, not the timing engine. The timing engine doesn't provide timestamps. It just steers the clock if it's a client, or even if it's a server and it's steering to an external reference. So the protocol engine has to have access to timestamps from the local clock.
Okay. No, I was concerned that the timestamp T1 was sent from client to server.
Yeah, I mean, my thought is the timestamps come either from an operating system clock system or from some kind of hardware counter that you can access through a driver. And the protocol engine should just be able to pull those directly when it needs to as it's constructing a packet, or filling those fields in a packet.
Okay, thank you.
Mark, you got in the queue and then you popped back out and put it in the chat. Did you want to pick it up? Excellent. Go ahead, Mark.
Yeah, my question was basically about precision time protocol. The IEEE 1588 or whatever one standard it was, I think had us down to femtoseconds precision, which is a little bit better than a quarter of a nanosecond. I'm just curious if we're going to need something to be able to extend to sub 32-bit, the second low-end bits for the protocol, if they're going to be having PTP reference clock.
That's a good point. When we did that in 1588, we wanted to make sure that we had enough resolution that we wouldn't have to address this for a long time again. And this was in anticipation of things like White Rabbit, PTP. But some of the niche applications where people want to use NTP rather than PTP because NTP has certain properties they like or they're used to it. Our precision applications, especially in finance, people are looking at White Rabbit because
I know.
I think they would want the same, at least down below a nanosecond, for the future when we get there with NTP.
Well, yes, I'm just suggesting that normally PTP requires special hardware, latching and other things. It gets quite tricky to do that over the NTP protocol, which has a fair amount of slop in it. The PLL's getting us down to maybe a microsecond on a really accurate system. But I'm just curious because the finance industry does typically want to make sure that trades happen, in linear time rather than all at once. There are a lot of them that get bunched up at a microsecond. So they want sub-microsecond for sure. Wasn't sure what we can do about that for the NTP definition protocol and whether that had to be considered in this set of changes for NTP-v5. That's all. I'll take the rest of the conversation off.
Okay, yeah, and it's a really important topic, I think, if you're looking at a next generation. And I know in the case of PTP, because of backward compatibility, we couldn't change the timestamp field. And so we end up putting that extra precision in another field that was a new field, which is a little awkward, but that was needed to be done. And I should point out, NTP servers these days typically have, the commercial variety at least typically have hardware timestamping, which is really the magic that makes PTP work. And many of the clients have hardware timestamping on a NIC card that's used, and so there's one aspect that can drive things towards needing higher precision.
Go ahead, Jose.
Hi, everybody. Could you hear me?
Yes.
Thank you. Well, just to say that if you want to synchronize in one network, I'm along internet, it's quite difficult if you want to go under microseconds because traffic, because the asymmetry into the links, the connection to the server are normally asymmetrics, and this gives you a problem where you perhaps you can synchronize frequency, but not exactly time. Perhaps you got a very low frequency synchronization and with an unknown delta time. Okay, if you do this in some network where you can be sure that the path go and the forward and come back path are symmetric, you can got normally very low number. I mean of the order of microseconds. But to go under nanoseconds, the magic part of PTP is doing because a local hardware, and also because this is running normally in local area networks, where the paths are normally symmetric, and they are very, very fast. But this is for me the limitation. I have a proposal on TikTok working group that perhaps you can see about that. And if you want, I can collaborate to this new proposal in order to bring up my knowledge about this particular situation. Thank you.
Thank you. I would think I would agree with everything you said, that we can, just because we make a very high resolution to our timestamp doesn't mean that you can actually always achieve very high accuracies. There's limitations even with the most clever clock control algorithms. There are limitations due to the network conditions that set what can be achieved. But I think for some of the niche applications that people might want to swap in different clock control, there tend to be more local, smaller networks with few hops. And in the finance case, they will typically have 2 or 3 hops through switches that are the fastest ones that money can buy, 30% loaded with small packets only. And so in that kind of situation, you can really achieve very precise time transfer.
Go ahead, Miroslav. Miroslav, did you want to speak? Maybe you did not intend to get in the queue. Going once, going twice for Miroslav.
Or if he's having technical problems, I'm happy to answer questions on the email later.
Oh, yep, there, I hear him now. Yes, go ahead, Miroslav.
I forgot what I said. I would like to add that we have a document on the wiki about NTP-v5 requirements, and one of the items is the precision of the timestamps.
Yes.
So if you have any comments or suggestions, you can add it there or on the mailing list. And also, I would like to add that even for PTP and White Rabbit, they have just reached the limits of the quarter nanosecond precision that NTP is using. So going below that 1/4 nanosecond precision might not be needed in near future. Like the hardware timestamping on computer that's typically used is precise to maybe hundreds of nanoseconds. It's difficult to calibrate these errors out. So, and most operating systems work with 1 nanosecond resolution system clock. So, yeah, that's might be important, but probably not in near future.
Well, I would say that it's certainly a lot of trouble to get down below microsecond. Talking about nanoseconds or even below a nanosecond is a lot more work, and only works in kind of small networks that are sort of carefully calibrated and all this sort of thing. However, the finance community has, what I'm hearing from them are 2 things. One is we're used to NTP. We like, or at least for some people in the finance world, they like NTP more than PTP because they're used to it, and they like the they like the voting algorithms that clients have. Makes it more robust. And they're at the same time looking into White Rabbit PTP because for trades, nanoseconds matter. And I'm sure there are other applications that might have the same property where like they have been doing NTP for a long time. They're used to it. They like it. They use certain aspects of NTP that are not available in PTP, but now they're moving to refine their application, and they need more precision. And so we might find that there are some niche applications that really are going to want to do things like cable and phi calibration and have very fine resolution for timestamps.
Okay. Anybody else? I don't see anybody else in the queue. Oh, Harlan's in the queue. Go ahead, Harlan.
Any else? Do you mean anything else on any topic?
No, I mean anything else on this document or this presentation.
Never mind.
Okay. All right. So so if there's nothing else on this, thank you, Doug. I'm going to pop you out of the queue. Martin, if you want to go ahead and start getting in the queue, that would be great. So Dieter, he wants to, okay, there you go. Just to wrap up that last subject, I want to thank Miroslav for reminding us that we do have a detailed list of requirements on the wiki. I think one of the things that we need to do.
Okay, so I hope you can hear me now.
Yes, we can. Go ahead.
Okay. Short question. So I'm
well, we could hear you, but now I can't hear you. Dieter, can you share your screen, please, instead of Martin? Okay. So here's the slides. All right, audio only. Let's go, Martin.
I'm a bit worried because I lost the audio stream. Okay. Oh, I can hear you now.
Yeah,
Okay.
I can hear you now.
I don't know what's going on. Okay, so I guess it works now. Yeah. I was an attendee at the IETF Hackathon last week, and so this is just a short summary of what happened. Tina, can you next slide, please? Okay, perfect. Yeah, our primary objective was interoperability testing between the NTS implementations in order to verify that the communication works correctly. And as far as I know, all of our implementations based on the latest draft version of NTS 28. Further goals were extended tests to check the compliance with the NTS specification in the implementation, and we also carried out some performance tests. Next slide, please. Okay. Our test setup included a total number of 14 NTS-capable NTP servers in different countries. They were located in the USA, Germany, Netherlands, Singapore, and Sweden. And also we have 5 different NTP implementations with NTS support right now. I guess the most popular are Crony and NTPsec. We also have Cloudflare, an implementation from the Ostfire University NTPO, and a hardware-based solution on FPGA. Next slide. Yeah, so interoperability tests were successful. All implementations talk to each other, and what we found out, everyone is very strict in what they send, but they are not very strict or not strict enough in what they accept. And also we still have issues with international connections. It's the same problem. We had packet loss as we have in the recent years. And therefore the NTS key exchange works, the first phase, but the secured NTP connections does not. And the reason for this are the NTP packets, which are larger than unsecured packets and therefore filtered out on the way. And I guess there's nothing we can do about it. So I hope in the future this don't happen again. Next slide, please. Yeah, the advanced NTS tests. Miroslav has developed a tool for the extent tests, which covers the NTS key establishment protocol, and it checks compliance with NTS specification. Thanks for this, Miroslav. It's a pretty great tool, and we can download it on GitHub. And it offers many fails, but not serious problems. So the most implementations tolerate non-critical errors instead of aborting the processing of the packet. So several of these bugs are known or intentionally accepted. So, for example, some implementations also accept TLS 1.2, but since the last version of NTS, only TLS 1.3 is allowed. So we can fix them pretty fast, and I think this is not a great deal, not a big deal. And few bugs were fixed during the hackathon too, so I guess the implementations make progress and the quality increases. Next slide, please. Okay, the results are available on Google Docs, so you can see all test results and the testing details. Here below you see the figure of one testing. Many cells are red, but as I said, there are non-critical errors, non-critical fails in the most cases. And next slide, please. Okay. The performance test based on the testing tool from Miroslav 2. Not everyone have done this test, and some implementations were achieved at about 3,000 NTS key sessions per second, and I guess this is a good value. This value depends strongly on the implementation and the hardware performance, so we have to consider this. And next slide. Okay, thanks. This is the conclusion. The hackathon was successful and the testing tool was pretty useful. Also, the interoperability is still good, and also we have no further issues identified. So I guess NTS is therefore ready, and I hope we achieve the RFC status very soon. Last slide, please. Thanks to all members and organizers. Here is the team the list of the team members. We were 10 members, as I can see. Kai Heine was the first time at the hackathon. It's my colleague, and he managed the test of the Swire University. On the right side, you see the links, so you can download the NTS implementations and test yourself. And yeah, I hope, yeah, this is, yeah, fine. Okay, so that's it.
Thank you, Martin. Does anybody have any? Go ahead. Go ahead, Miroslav.
About those failures reported by the testing tool, it's not an issue for the current clients, but if the key establishment protocol is extended to support NTPv5 or maybe a completely different protocol, these issues could be a real problem for the client to handle if it's asking for something else than the NTPv4 next protocol, and it gets a response with NTPv4, it may not understand the response correctly, and this would complicate the client. So I think the issue is that some of the server implementations just don't look at the request and just assume it will always be a NTPv4 client and just send a bunch of cookies and that's it. So yeah, maybe it's not a big issue now, but it may be in the future. And the specification clearly says when the server must respond with an error or so. Yeah. So it would be good if the server implementations could be improved to handle at least the next protocol correctly.
Yeah.
Thank you, Miroslav. Anything else, Martin? Any other questions?
No, not for me.
Okay.
Yeah.
I did want to especially thank Miroslav and Martin and Krister from NetNode for really sort of being the backbone of the team. I think you guys are doing great work and making progress. So, all right. So going back, I wanted to go backwards just a little bit to the discussion we were having on NTPv5 and the wiki. We're interested in looking at the chartering aspects of that. And also it would be helpful if we had some documentation in place. So we've discussed rechartering in the past, and we don't have a charter prepared today. So I don't know if anybody has any thoughts on this or any comments about what the next steps would be. And all right, with that, we will take that to the list. The next thing I have is Eric. Hi, Eric. Go ahead.
Yeah, I was just going to say that, it took a while for Data Tracker to pull up the current version of the charter. So sorry about that.
Oh yeah, it's a little out of date.
It's yeah, it is. Some kind of updating would be good one way or another, and it would be a natural time to fold in an attempt to do V5. If anybody wants to suggest some text or some motivation for doing NTPv5, that would be sufficient for scoping the work in the charter. I think that might be helpful. Maybe that could be down the list. Or perhaps the chairs and I could take a stab at a rewrite and share that.
Okay.
I'm I'm assuming that there's no like that people do want to move forward with NTP-V5 work. So
I think conversations to date have indicated they are interested in moving forward. The question is really sort of the scope of what would be included. And I think that's some of what Miroslav tried to get to when he helped build out that wiki page. All right. So the next meetings, we've been trying to do like a virtual interim roughly every 6 weeks or so to keep us on track. I'm looking at the week of September 1st or the week of September 8th as the next meeting. Is anybody aware of current things that would conflict with those? Okay. And that brings us to any other business. Does anybody have anything else they want to mention? Go ahead, oops. Yeah, go ahead, Harlan.
Just to ask, is there a reference implementation of the Yang data model yet?
I don't know, and the authors are not in the meeting.
Okay.
So
That was
I'm
it.
not. I know Deirdre was checking with them in the context of doing the Shepherd write-up, so you can check back in a few days.
All right, thank you.
All right.
That's true. That's one of my questions as well.
Right. That I thought we had discussed it when we were talking about the Shepherd write-up yesterday, so that's good. Any other questions? Okay, so with that, I give you back a little over 15 minutes of your day. Thank you, everybody. I think this went pretty well. And with that, I adjourn the meeting.
Bye, everyone.
All right. Thank you, everybody. Have a good day. Happy trails, all that thing.
Thanks.
Hi, Mark. The meeting minutes will be posted under the data tracker proceedings for IETF 108.